Hello viewers, I am CH Nagaraju from TSWREIS Boys Mudigonda. My dear friends, before entering into our chapter, our lecture, let's see the objectives of our lecture at first. The objectives are to understand the characteristics of electromagnetic spectrum and to compare the relationship between wavelength and frequency of electromagnetic waves and to know the applications of electromagnetic waves. These are the objectives of our lecture. My dear friends, in our daily life, we are very familiar with the mobile phones, that we can share our photos, videos, files from one mobile to another mobile. And also, additional to this, we can even talk to the other people using these mobile phones. I mean, we can communicate with other person using these mobile phones without any direct wire connection through a long distance like thousands of kilometers. Now just think, how is it possible to contact with other people using these mobile phones? And what is the invisible connection between two mobile phones? Just think. At the end of this lecture, we will try to answer all these questions. Right? On a fine day, when I went to a lake, I was thinking about all the solutions for these questions. Then I simply took a stone and I just thrown it into the water. At that place where I have thrown the stone into water, I found that the stone made some ripples, some circular waves in water. Now what are these circular waves exactly? What is meant by a wave? Just let's see. By looking into the meaning for this word wave, in our science, a wave is just a kind of disturbance that can travel through space, liquids, solids and gases. Simply, a wave can transfer energy from one place to another place. Basically, the waves are divided into two types. One is longitudinal waves and another one is transverse waves. To understand about these two types of waves in a better way, please look here. For example, this is the direction of wave propagation, and if the particles of a wave move parallel to this direction of wave propagation, then those waves are called as the longitudinal waves. And in these longitudinal waves, compressions and rarefactions are formed. But if the particles of the wave move perpendicular to this direction of wave propagation, then those waves are called as transverse waves. In these transverse waves, crests and troughs are formed. So longitudinal waves and transverse waves, these are the two types of waves. Now, and also there are some parameters for waves, and it is very important to know about the parameters of waves. There are two main parameters of waves. The first one is wavelength. In a wave, the length between two crests or troughs is called as wavelength, and this wavelength is denoted by lambda. Now the second parameter is the frequency. In the number of waves formed in the unit time is called as frequency, and this frequency is denoted by nu. So here the parameters wavelength and frequency, these are the two main parameters of waves. If we search for the best example for the transverse waves, we will get the electromagnetic waves. Now we will discuss about the electromagnetic waves. These electromagnetic waves are nothing but the waves which travel with the velocity of light and consist of both oscillating magnetic field, electric field perpendicular to each other and also perpendicular to the direction of wave propagation. Then such type of waves are called as the electromagnetic waves. The best source for these electromagnetic waves is sun, because sun is a great producer of waves. Sun can produce a number of waves, so many waves. For example, when the sunlight or white light which is producing by the sun is one of the example for electromagnetic waves. So whenever this white light or sunlight falls on a prism, then in that prism refraction and dispersion takes place. So the white light in the dispersion, this white light will splits into a different sequence of colors like violet, indigo, blue, green, yellow, orange and red. So this sequence of colors is called as the visible spectrum or simply VIBGR, and this VIBGR is one of the example for electromagnetic waves. So sometimes whenever we stand under the sunlight, we may get some warmness on our skin, and that warmness is due to another kind of electromagnetic waves which are producing by the sun, and those electromagnetic waves are the infrared rays. These infrared rays are also one of the example for electromagnetic waves. And another example, ultraviolet rays. These ultraviolet rays are directly producing by the sun, but whenever these ultraviolet rays falls on our skin, then it leads to cause skin cancer. So the ozone layer of our earth, the ozone layer almost resists all ultraviolet rays, and this ozone layer protects us from those ultraviolet rays. So these ultraviolet rays, visible light or VIBGR and infrared rays, these three are some examples for electromagnetic waves. Other than these, there are also some other electromagnetic waves. They are gamma rays, X-rays, microwaves and radio waves. So if we keep all these electromagnetic waves, if we arrange them in an order, in a sequence, by depending upon their frequencies or wavelengths, and the arrangement we get here is called as the electromagnetic spectrum. Now, and that is my topic, the characteristics of electromagnetic spectrum. Before entering into the characteristics, let us learn about the electromagnetic spectrum. So far in our lecture, we have discussed about what is a wave, the types of waves and parameters of waves and electromagnetic waves. Further, we will discuss about the electromagnetic spectrum and the relationship between wavelength and frequency of electromagnetic waves, and also characteristics of electromagnetic waves. And we will look on the specialities and characteristics of all 7 electromagnetic waves in detail. Now we will discuss about the electromagnetic spectrum. This electromagnetic spectrum means it is an arrangement of all electromagnetic waves by depending upon their wavelengths or frequencies. If we look on the arrangement of all electromagnetic waves, either increasing our wavelengths or increasing their frequencies. but there is an interesting relationship between this wavelength and frequency of electromagnetic waves. For example, if a wave has more wavelength, then it has less frequency. If the wave has less frequency, then it has less energy. But if the wave has more energy, then it has more frequency but less wavelength. Here wavelength and frequency are inverse proportion, and frequency and energy are direct proportion. This is a wonderful relationship between wavelength, frequency and energy of electromagnetic waves. If we look on the arrangement of all electromagnetic waves, from the shortest wavelength, that means highest energy, to longest wavelength, that means lowest energy, we will get the arrangement of electromagnetic waves like gamma rays at first, then after X-rays and ultraviolet rays, visible light, infrared rays and microwaves, at last radio waves. Now let's move to the characteristics of electromagnetic spectrum. If we look on the characteristics of electromagnetic spectrum, we will have two main characteristics. The first one is, in the electromagnetic spectrum, all electromagnetic waves can travel through vacuum. That means all electromagnetic waves does not require any medium to travel. They can travel through vacuum. This is first characteristic. And the second one is, in the electromagnetic spectrum, all electromagnetic waves will travel with the same velocity of light in vacuum. That velocity of light is equals to constant value 3 into 10 to the power of 8 meter per second. And from this characteristic, we can get the formula, that is C is equals to nu lambda. Here C means speed of light in vacuum, nu lambda means wavelength, and nu means frequency. The product of frequency and wavelength is equals to the speed of light in vacuum, that is equals to constant value 3 into 10 to the power of 8 meter per second. We have this constant value because this value is equals to product of frequency and wavelength. But the relationship between frequency and wavelength are inverse proportion. So that's why we can have the constant value for the velocity of light in vacuum. So these are the two main characteristics of electromagnetic spectrum. Now let's see the each specialities and characteristics of all 7 electromagnetic waves in the electromagnetic spectrum. At first, let's see the most powerful electromagnetic waves. They are gamma rays. These gamma rays has very less wavelength but more energy, because wavelength and energy are inverse proportion. So that's why these gamma rays has less wavelength, so it has more energy. These gamma rays has more energy, so that's why these gamma rays are called as the most powerful electromagnetic waves. When we keep an uranium there, then the uranium will decay itself, and from there we will get gamma rays, and those gamma rays are used to kill or cure the cancer in our human body. So this is about the gamma rays. Now let's move to second most powerful electromagnetic waves. They are X-rays. These X-rays are particularly used to identify the broken bones in our human body. Now let's see the another kind of electromagnetic waves. They are ultraviolet rays. These ultraviolet rays are directly producing by the sun. That means sun is a source for these ultraviolet rays. Sun is a source for these ultraviolet rays. But whenever these ultraviolet rays falls on our skin, then it may leads to cause skin cancer. So that's why the ozone layer of our earth protects us from those ultraviolet rays. Anyhow, these ultraviolet rays are also used to kill the harmful bacteria which is present on our earth. So this is about the ultraviolet rays. Now let's move to this special kind of electromagnetic waves. That is visible light. This visible light is a special kind of electromagnetic waves because only this visible light is visible to our naked eye. Remaining all other electromagnetic waves are not visible to our naked eye. That is the speciality of this visible light. The reason for this visible light to appear is that this visible light has the wavelength in between 400 nanometers to 700 nanometers only. Moreover, our eyes are very sensitive in this area. So that's why this visible light is visible to our naked eye. Remaining all other electromagnetic waves, they don't have such type of wavelength like visible light. So that's why they are not visible to our naked eye. Only this visible light is visible to our naked eye. And this visible light is very, very important in our life because this visible light helps us to see everything in the nature. See, you people are looking me and I am seeing everything in the nature. That is because this visible light. Without this visible light, we can't see anything. We can't see anything. So this visible light is very, very important in our life. And as we discussed before, whenever the sunlight or white light falls on a prism, then in that prism refraction and dispersion takes place. Due to dispersion, the white light will split into different sequence of colors, which is called as Vibgyor. Like that, in the same way, whenever the rain and sunlight falls at the same time, then whenever the white light falls on the water droplets, these water droplets will act as a prism. In the same way, in that droplet, refraction and dispersion takes place. Due to dispersion, the white light or sunlight splits into different sequence of color, that is nothing but Vibgyor. So due to presence of many droplets, it appears as a huge rainbow. So in the formation of rainbow, this visible light is very important. That is the importance of this visible light. And the main source for this visible light is sun, because sun is a great producer of waves. Sun can produce a number of waves, so many waves. Now let's move to another kind of electromagnetic waves. They are infrared rays. These infrared rays are also producing by the sun. The main source for these infrared rays is also sun. By using these infrared rays, we, the human beings, had prepared some cameras. By using those cameras, we can even get the photography of nocturnal animals. I mean, we can get the photo of animals even in the night time also. That is a speciality of these infrared rays. So by using these infrared rays, we have prepared some cameras. Those cameras are also used in the warfares as the security cameras. So this is about the infrared rays. Now let's move to the another kind of electromagnetic waves. They are microwaves. These microwaves are particularly, most of these microwaves are used in the micro-ovens to cook the food. These microwaves have the characteristic or specialty to cook the food. And these microwaves are also used for the long distance telecommunications like satellites. This is about microwaves. Now let's move to the last kind of electromagnetic waves. They are infrared radio waves. These radio waves are particularly used for the standard broadcast radio and TV, and they are used for the air traffic controls, and they are used for the navigation purpose, and even they are used for the remote control toys. So there are many uses for these radio waves. Now let's took overall advantages of all electromagnetic waves, that is electromagnetic spectrum. So there are many advantages. The electromagnetic waves are used to kill the cancer. They are used to identify the broken bones in our human body, and by using those rays like electromagnetic waves like infrared rays, we can get the photography of nocturnal animals, and micro electromagnetic waves are used to cook the food. And in the beginning of our lecture, we have raised a question. We have raised some questions like how is it possible? How is it possible to contact with other people, to communicate with other people using these mobile phones? And what is the invisible connection between two mobile phones? The unique answer for those questions is the electromagnetic spectrum, electromagnetic waves. So there are many uses. Though there are many advantages, there are also some other disadvantages. Now let's see. Some gamma ray, electromagnetic waves like gamma rays and X-rays, they are used to sometimes these rays can damage the useful cells in our human body. And some radio waves and microwaves, they can cause some harmful disorders like heart cancer, brain cancer, and many diseases. And if we continuously look at the visible light, after some time it may leads to loss the eyesight. So there are many disadvantages also, though there are advantages. So now let me conclude my topic on the characteristics of electromagnetic spectrum. So as we discussed before, there are two main characteristics. One is all electromagnetic waves can travel through vacuum. They doesn't require any medium to travel. Then the second one is all electromagnetic waves travel with the same velocity of light. That velocity of light is equals to constant value 3 into 10 to the power of 8 meter per second. So these are the two main characteristics of electromagnetic spectrum, and so far we have discussed each specialities and characteristics of all 7 electromagnetic waves. Different electromagnetic waves has different characteristics, different specialities. At last, I am going to thank a heartful thanks to my subject teacher Geeta Krishnaveni madam and my Mudigonda school principal sir K. Raghav Reddy sir and all my Mudigonda school, because they worked a lot for my preparation, and a kindful thanks to this TSAT channel for giving this golden opportunity to me, and thank you for watching. Thank you all.